Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. In this tutorial video today, you will learn what is P&ID drawing and how to read P&ID drawing, so let's see. A piping and instrumentation diagram, or P&ID, shows the piping and related components of a physical process flow. It's most commonly used in the engineering field. In other words, it is a diagram which shows the interconnection of process equipment and the instrumentation used to control process. Function and purpose of P&ID. P&ID are foundational to the maintenance and modification of the process that it graphically represents. At the design stage, the diagram also provides the basis for the development of system control schemes, like hazard and operability study. How to read P&ID drawing. To read P&ID drawing, first of all you need to understand piping or connection line. As you can see from the table that, these are the few common piping or connection lines, which is used in P&ID drawing. For example, any electrical signal is represented by dotted line, and solid line represents straight line pipe. Now, let's go into more details and understand the different meaning of the symbols. In this symbol, first letter represents parameters that are being controlled or monitored. For example, it may be flow, level, temperature, or pressure. In this example, it is flow. Next letter indicates types of control device being used for measurement. For example, it may be transmitter, valve, or controller. In this example, it is transmitter. Bottom number is logical numerator, and it is used for identification of equipment. In this example, it is number 28. Circle with no line indicates that flow transmitter number 028 is mounted in the field area. Number of the equipment is very useful for identification, especially when diagram has same equipment or more. Now let's have another example. In this example, level. I for indicator. T. Transmitter. A single line means the display is located on a main control panel or a computer screen near the control room. And the number is a loop number. Now let's have a look in this example. As we can see, this example has two flow indicator controller. So, number will help you to identify which is FIC number 1 and which is FIC number 2. Same thing with flow indicator transmitter. Number will help you to identify which is FIT number 1 and which is FIT number 2. Now, let's read this P&ID drawing. Here, flow element such as orifice plate is connected with flow indicator transmitter numbered 001. This flow indicator transmitter 001 is mounted in the field area. And it is connected with flow indicator controller numbered 001. Dotted line indicates that it is connected by electrical signal line. And flow indicator controller numbered 001 is connected with flow valve numbered 001. In addition to this, flow indicator controller numbered 001 is also connected with ratio controller. And ratio controller is in DCS or in PLC. The other side. Here, M indicates that flow element is electromagnetic flow sensor is connected with flow indicator transmitter numbered 002. And flow indicator transmitter numbered 002 is connected with flow indicator controller numbered 002. And dotted line between these two devices indicates that electrical signal line is being used to connect these devices. As we can see, flow indicator controller numbered 002 is connected with I to P converter. It is milliampere to pressure converter. And the output of I to P converter is connected to control valve numbered 002 by using pneumatic line. Finally, here we have identification letters table for your reference. In some cases, a letter can only be used as a succeeding letter. For example, the letter D would never be used as a first character, but it may be used as a succeeding letter to indicate differential. Thus, the combination PD is valid and would indicate the function of the device is pressure differential, that is, differential pressure. Thank you so much for watching and have a nice day.